I'm going to use my camera as a bow tie today. Again, bow tie webcam. Because I want to show you guys something that we could do when it comes to multiplication, all right? Now, typically, when we are doing our work, we're doing multiplication problems. You guys will, use your paper like this because, this is how we've learned to write. So what happens is we'll do our problems and they'll do like 3.7 times 0.03. And they're going here and we have kids start doing their work. And what happens is kids are sloppy. And then what happens is they start making really weird mistakes. Okay. Now, obviously, I did not do this correctly. But we start counting and they're like, okay, so I need to put my decimal right here. You guys can't see anything? I can see me. So you see blurs. All right, let's try this then. I'm back up here. Where's my phone? Well, I can't use the whiteboard. That's the problem with it. Because I need specifically lines, and I don't have my iPad today, which would have really helped. Let's try this. There we go, right? Can you see that better? All right, there we go. So the problem is you guys are sloppy. And I'm not going to, call anybody out, but cough, cough, boys tend to be sloppier than girls. I propose that if you find that you struggle with math, like keeping everything neat and organized, that you actually turn your paper sideways. Oops, my camera just fell over. So I'm going to do that same problem again. 3.7 times 0.03. So what I want you guys to notice straight away is that each number, I now have columns that I can keep everything in. Okay? So now I'm going to do my math. 3 times 7 is 21. 3 times 3 is 9. 2 more makes it 11, right? I've got to put my placeholder in here. 0 times 7 is 0. 0 times 3 is 0. And I go through and I bring everything down. Okay? I have 1 decimal place up here. I have 2 decimal places up here, which means I move my decimal 3 times right here. So my answer is going to be 0.111. You see how easily I can keep everything in a column? So I don't have to worry about making mistakes of is it in this column or this column? It's helpful in multiplication, yes. And what you'll find also is eventually when we do division, you can turn your problem the same way. Right? Put that there, put that there. So your problem is now 337. 3 goes into 3 one time. 1 times 3 is 3. 3 times 7 is 2. 6, 1. Put your decimal on. Carry that down. 3. Okay, 12.3. Everything with decimals, sorry, not with decimals, but multiplication and division, it's just real easy if you just do a simple thing like turning your paper sideways, because now you got all of these lines to help you. Olivia, do decimals, so multiplication and division, the decimals do not have to be in a line. No. Adding and subtracting is the only thing that decimals do have to be in a line for. Well, I've got my camera down here. I'm going to do this. And the reason is that's a trick that you've been taught. And unfortunately, you're not explained as to why the trick doesn't work. So what happens is when you're lining up the place values, you're lining up your decimals, what you're really doing is you're lining up your place values. Because if I had you come over here and we're going to look at this problem, 11 plus 3 equals 41. What's my problem? Is 11 plus 3 41? No. We all know that this means 3 ones, that this is a 10 and 3, or 10 and a 1. So when I put these together, I'm going to have 14, right? Going back to your 1s and 10 sticks. The same thing is happening over here. We teach you to line up your decimals because what we really want you to do is to line up your place values so that you're adding 1s to 1s, 10s to 10s, tenths to tenths. Okay? So that way, when we're adding 3 tenths and 1 tenth equals 4 tenths. 2 1s and 1 1 equals 3 1s. We just tell you to line the decimals up because it's easier for a kid to understand. Unfortunately, that information doesn't seem to get compared or get relayed to you, though, as to why we do it. The first one I did wasn't lined up. You mean this one right here? That's because in multiplication, it doesn't matter. In multiplication, let me take you down the math rabbit hole, all right? In multiplication, if we're doing a problem, okay? If we're doing a problem in multiplication, we pretend like those decimals aren't there, right? So we pretend that the decimals aren't there, and you just multiply like normal. What we're really doing, the secret behind it is I'm really multiplying this times 100 because I want to make it so that there are no decimals. I'm multiplying this times 10 because I don't want a decimal. Oops, right? So my problem that I'm technically working on is 415 times 12. And I can do that math real easily, right? 0, so 10, so 2, 3, 8, 0, 5, 1, 4, 0, 8, 9, 4. Boom, right? Done. But, and ouch, we still need to deal with our decimal. Right now, my answer, I multiplied one of them by 100 and one of them by 10. Yeah, I just kicked my table. It's okay. So my answer, this, is technically times 1,000. It's 1,000 times bigger than what my actual answer is right here. So that's where we come back and we count our decimal places. I have 2 decimal places here. I have 1 decimal place here. So we have to move them back so that I can get 4.98. Okay. So 4.15 times 1.2 equals 4.98. 415 times 12 equals 4,980. So my answer, the numbers are the same, right? The decimal place is different. So technically, when we multiply decimals, we're multiplying to get rid of the decimals, and then we're bringing them back in on this last step right there. That's why the decimals don't matter. How many people's brains are melted by math right now? Have I answered some questions? Or did I explain something that you guys are like, oh, that's interesting? So I'm going to admit, that's the thing that I miss the most about having like a traditional traditional classroom is because we could do stuff like this all the time, and we would do stuff like this all the time. I'd explain the magic behind the curtain, right? So I'm going to post this video on our It's Learning. I'm going to post it on my YouTube as well. You need the 10 times the math to blow up my brain. Okay, good. Your face scared me. Your face scares me too, Leo. I think I'm up to like 28. But yeah, so I'll post this so that you guys can rewatch it if you want.